Hey everybody, welcome back to the channel. In this video, we're going to continue building our application SitRep here, and I've decided to take a hard left turn on some of the technologies that we're using to make it just a little bit more simpler, and then we can add on down the road if we want to. So basically, from the last part, I've removed the front-end application, and I've also removed the Aspire orchestrator. And that's because I was having a lot of issues working with it. And the main reason is that I'm just not quite familiar enough for it to be enjoyable and for it to make sense. And the other thing was the speed of spinning up all of the servers and getting them to run. It just seems like there was a lot of delay when I can just run this API in just a couple of seconds, and the front end as well. I'm not sure why Aspire takes so long to spin them all up. I've also decided to move away from Keycloak at this point, and we can implement that at a different point. Instead, we're going to start with ASP.NET Identity using EF Core as the data store for that. So our goal here for today is to actually wire up the API to use ASP.Identity and add a login endpoint and a register endpoint. So let's go ahead and talk about what I've already done off screen here, because there's a lot of manual work required for building out the data project here, which is all the EF Core entity classes. And so let's go ahead and explore what we've already done. So I'm going to jump over actually to the solution view, and let's look at this sitrep.data project. So all this is the app DB context, which is the EF Core context class, and we're inheriting from the identity DB context. So this is what gives us the ASP.NET identity using Entity Framework as the data store. And then I believe we briefly reviewed the data model, but I've created all of the entity classes with all of the navigation properties and stuff like that. I'm not going to go into all of these entities, but basically here's the important thing, is that our user class now inherits from identity user. That's going to give us the ID, username, all the user related profile things, as well as password hashing for free out of the box with this identity platform. Back to the DB context, we're calling the base on model creating. That's going to call the base constructor from the identity DB context that we're inheriting from, and that's what sets up a lot of those things. And then I'm just doing a couple of overrides here, which is to say that I don't like if I run the migration as it is right now, it will actually create the tables, like the user table would be ASP.NET users and ASP.NET roles. So I'm basically just calling this toTable on these tables that come out of the box with the platform to a more friendly name, so I don't have to have that ASP.NET prefix on these. And then the apply configurations from assembly. This is going to apply all of these configuration classes when we run the migration. And this is obviously just configuring all the foreign keys, the indexes and relationships, and also setting some limits on some of the properties to optimize this a little bit. And then we have a few enums for issue priorities and roles and stuff like that. So this is looking good. So we should also look at the project file here. So the packages that we are referencing here is our identity entity framework core. And this is what gives us the identity package, or the ASP.NET identity with EF Core. And then obviously our main entity framework package and the NPG SQL for using Postgres. Okay, so let's go ahead and get started with our changes here. Basically, I want to come up to the launch setting and just simplify this. I don't want an HTTP profile. I just want one consistent thing to run. So I'm just going to remove the HTTP profile and also specify the 5001 as the base URL for the API. And then we want to make sure that we have the ASP.NET Core environment set to development. And then let's go ahead and check out the project file for the API. I've added a reference to the data project. I've installed the fast endpoints package, the JWT bearer package, the design package for running migrations, as well as the Open API and the Postgres package as well. And then out of the box in .NET 9 or 10, they stopped using Swagger. And so I added Scalar as an alternative to Swagger so that when we run our API, we can navigate to the browser and see all of the endpoints that are available, which can be helpful. So now let's go ahead and look at the user secrets because we want to add some secrets to support our changes today. So I'm going to go in here and basically we are going to set up our JWT authentication. And so we're going to need a signing key, which is this value here, and then an issuer and an audience. And then we're also going to want a connection string to our database. So that's what this is, and it's in the connection strings prefix here. That will be important later. And let's jump over to our program CS and let's get started here. So we want to remove some of the old things that were still in place after I nuked the Aspire orchestrator and Keycloak. So we're going to get rid of that, get rid of that, get rid of this. For now, we're going to remove the add authorization. Don't need our default. We'll leave the API service, the root API, and then we're going to get rid of our weather forecast. No more default endpoints, app.run, and we don't need this record anymore. Okay, so let's come up here and let's go ahead and start adding the things that we want to add. So the first thing I want to add is our DB context. So right here, I'm going to paste in this code here, which is adding the DB context to the services here. We need to reference our app DB context namespace, and then we're using the use npg SQL. Again, this is coming from that npg SQL package in our API service project file. And then this is using the get connection string. So that's what looks at that connection strings : Postgres. That's why it's important to keep that naming convention here. So this is going to register our DB context class in our dependency injection. So we can request this in other services and use it. And we're obviously wiring it up to this Postgres connection string. And we will talk about how to get the database running in just a second. Actually, let's do that right now. There's also a README file that I added, and this gives you a command here to run Postgres on Docker. So if you just run, this is going to run Postgres version 17, and it is mapping the port and setting the user and the database name and the password, which is correct, literally SitRep_password. So this, we're running this in development. So this is obviously not like a secure password, stuff like that. But if you run this command here, then it is going to match the connection string that we added here. You can change that if you're following along and building this on your own. Feel free to do it. Back to program CS here. We've now added our DB context class. So let's go ahead and add the next thing. So now let's add this builder.services.add identity code here, and that is going to add our ASP.NET identity services to dependency injection and also register Entity Framework Core as the data store. So this is adding an implementation of identity information stores. And if we go into the add identity, services.add identity, you can see that it's adding authentication, a bunch of different schemes and stuff like that. And this will make all of the ASP.NET identity services available for us to use in our application. So we need to do a little bit more configuration to actually set up authentication and authorization. So let's do that next. I'll paste this in here and let's go ahead and talk about what we're doing. First, let's import our missing using statements. So we're going to add authentication and we're going to add our JWT bearer scheme. This is basically boilerplate code for adding JWT auth. So here's the call to the add JWT bearer. Basically, we're specifying what needs to happen when we validate the token. So we're going to validate the issuer, audience, and lifetime, as well as the signing key, and then pulling some values from configuration for the issuer and the audience. And then this is the signing key also coming from configuration. And then we need to say add to use authorization, or rather to add the services for authorization. And then when we come down here, we need to make sure that we actually have these use authentication and use authorization middlewares here. And then let's go ahead and add a CORS policy and just allow basically anything for right now for our front end. And that means we need to come down here and also do app.use CORS. Okay. The other thing is that there's a couple of options that we can do for our endpoints. We can use minimal APIs. We could use controllers. I'm not against either one of those things, but I don't really like the minimal endpoints. It just feels like there's a lack of organization, and I don't know, it just doesn't vibe with me very well. So what I like to do is I like to use a package called fast endpoints, which you saw earlier when we referenced the package in our project file. So we're going to register that here. And then down here, we need to say use fast endpoints. And then I'm going to prefix globally on all API. So if we create an auth endpoint, the full API would be the base URL /API/auth, whatever the route is. But that way I don't have to specify this in every single endpoint that I create. So the last two things that we need to do here is apply migrations on startup. So I'm going to paste this in here. This is going to get the DB context class and then hit this migrate async so that it will automatically ensure that the database is created when we first run, and also apply our migration that we still have yet to add. And then lastly, come down here in this is development. We'll go ahead and update this to map this scalar API reference so that when we run this, we have the scalar page and route available for us to reference. And again, this is actually referencing all the stuff that comes out of this add open API. So we also need this for scalar to work. Okay, so this is the groundwork needed for the changes that we're going to make today. So let's go ahead and actually let's run our migration. Switch over to my solution view. Not that I need that. And I'm just going to use the tooling in my IDE here to add a migration. It's the initial migration. My migrations project is the SitRep.data. My startup project is the API service. And we want to make sure that the app DB context is selected and not one of these other identity ones. And then it's going to output into migrations here. Let's go ahead and add that. Okay, so I had actually stopped the recording while the migration was running, and I basically finished the migration here, and then I also recorded the rest of this video and then realized that I had paused the recording and didn't resume it. So that's a bummer, but I basically was just wrapping up the migration and then also adding our initial endpoints. So no worries, I will re-record this section here and just cover the things that I did while I was not recording. Basically, the migration was created, and you can see here that it has created the migration script, and here's the ASP.NET identity tables, and because of our overrides, it has named them with our friendly names like the user table here and our role claims instead of ASP.NET roles and ASP.NET users. So that's looking good. And then when I run the API, it properly applied that migration, and we can actually look at our EF core migrations table. So from underscore EF migrations history. So if we run this, we get this initial. This is the migration here. So that has been applied to the database, which means we have all these tables. So that's looking good. So then back over to the code here, I'm going to show you the other things that I created to wrap up this video. Basically, I added a requests and a responses folders. That's going to hold all of our DTOs and our request objects and response objects that we're going to return as kind of our API contracts. So we have a login request, which is going to take in an email and a password. That's going to be our required. You need to log in with an email and password to get an access token. We have a register request, which at this point is going to take an email and a password and then also a workspace name. So when you register, you need to be part of a workspace, and then you can also join a workspace from the invitation, but that's not a feature that we support at this point. And then right now we just have an auth response, and that's going to return a token and expire at a user ID and the email. So now I already mentioned using controllers and minimal API endpoints, but what I want to do in this project is actually use a package called fast endpoints, which we've already talked about, and we've added that package to our solution here. So let's go ahead and look at what that looks like to implement fast endpoints in .NET 10 and in our project. So we want to have a register endpoint and a login endpoint. And let's start with the logical first one, which is you need to be able to register before you can actually log in again. So I'm going to jump over to the register endpoint and let's talk about what's happening in here. So when we create a endpoint using fast endpoints, it's basically a class per endpoint. So we have our register endpoint here. We have some dependencies that we are injecting from dependency injection. And then also we are inheriting from this endpoint class, which has some type parameters. And this is basically saying, hey, we're going to accept a register request and we're going to return an auth response. So you get this nice typed request and response model of this is what it accepts and this is what it returns, which is super nice. And then basically we have our override configure method here, and this is where we specify things like the route and allow anonymous or the permissions on the endpoint itself. So in this case, it's a public endpoint because we want anybody to be able to register. Therefore, we do not require authentication or authorization on this. And then for the logic itself or the handler, basically, we just need to override the handle async method. And here you can see that we accept a register request, which also matches the declaration up here. And then we also have a cancellation token for saving on resources if we were to cancel this request. So let's talk about what we require in this endpoint. So if we're going to register, we obviously need to set up a user, which probably means we need access to the database. So we have the user manager that comes from ASP.NET Identity, and then also the AppDB context class in our dependencies for this class. And then we also have this token service. We can look at the implementation for this token service and the interface in a second, but let's basically talk through what needs to happen when you register as a user in this app. So we already talked about requiring this workspace parameter. And so basically we have this slug helper that calls the slugify on the workspace name. So if I jump into this is the code here. It's basically making a slug out of a string input and returning that. So we do that and then we have this slug. So if my workspace name is my cool workspace, which has spaces, uppercase, first letter of that sentence, it'll basically return my dash workspace dash name. And so that's normalizing that into a slug. And then we first check, hey, does this slug already exist? Because it needs to exist, or it can't already exist. We can't override someone else's workspace. And we could have front end validation too, so that it's a more friendly experience that when you're typing in on the front end, it would be able to tell you if it's taken or not. But we also obviously want that validation on the back end as well. If the slug is taken, then we're going to return an error response saying, hey, this workspace with that name already exists. You can't use that. And then we have to check, okay, is the incoming user, do they already exist? If that's the case, then an account with this email already exists. And this is not a problem returning an error saying, hey, this email already exists. Doesn't that mean that you could figure out who exists on the platform? And the answer is yes, but that doesn't differ from a lot of large applications that already exist out there, like Gmail or Twitter or X or whatever it's called. If you go and you try to use well-known email addresses, it tells you that's already taken, you can't use that. So I think this is in line with the industry of returning, saying, hey, the email already exists, you can't use that. So then we want to create our user. So we're instantiating our user class and setting the email on this. And then we can use the user manager and use the existing create async method. Again, this is all coming from the ASP.NET Core identity. We create it using that user and the password. And then if that doesn't succeed, we'll return an error, but I really don't see a point where that's going to fail. That should work just fine based on the validation that we have for the email and stuff like that. And then we need to create a workspace. So we generate a workspace using a new GUID, and then we're taking that workspace name and also setting the slug, which is setting that. So then we save all that changes to the context. So then to return a response using the fast endpoints package, you return this send async, and that's sending back the response. And then in here, you can see we have the call to the token service, which is calling the build auth response. I'll probably refactor this at some point to say generate token. I don't think the token service necessarily needs to know that this is like building an auth response. It might just be responsible for generating a token. So this is the implementation auth response. Again, I'm going to change that to just return a token at some point, but here is the token service, which is basic boilerplate code for generating a JWT token. So we come in here and we add all of our claims. We get our key to sign it. We have our JSON web token handler. We create the token based on the descriptor here, and then we return that as our auth response. This class here is registered in dependency injection. So builder.addScoped, iToken service, and resolves to the token service class there. So that is the full flow for registering. I've actually already registered a user. So if we come over to here, come up here, and we look at our database, you can see that I registered with this hananiah.lindy@example.com. Back over to the code. Let's now talk about the login endpoint. So once I've already registered, I now need to be able to get a token. So very similar to the login endpoint, we have our login endpoint class that inherits from the endpoint, and it accepts a login request and returns an auth response. The route is /for login. So the full path is going to be /API/auth/login, because in program, we've actually configured our fast endpoints to have this API route prefix. It's an anonymous. We implement our handle async, which basically tries to fetch the user from the database based on the email. If the user is null, then you can't log in. That user doesn't exist. Or if it's not null, then we need to check the password. If that comes back as no good, then it's also an invalid login. So we return this generic message saying, hey, either the email or the password is wrong. If it gets by this check, then we can go ahead and generate the token using that same user and auth response from the token service and return a token. So we can go ahead and run this to demo this. We'll come over here and we can log in again. So I'm going to try to log in with my existing user, except my password is incorrect. So if I send this, I actually get back this error because it's actually password 01 exclamation point. If I send this now, then I get my token back and my response. Having the email in here is pointless, as well as the expires at. It's just for some additional information to kind of see what's going on, but you could get this expires at from the token itself. So really we could just return the token and the user ID or anything else that we need, but let's go ahead and register a new user. So I'm going to update the email here, and my workspace name is going to be my least favorite things. I think that doesn't exist. So if I send that, I get back a token. I could log in with that, +1, send, login. And then if I go to my database, I should be able to see my other user here, +1 add example, and the workspaces is my favorite things. That was from that first user. And then my least favorite things, which is this workspace for this member that I just registered. Okay, so that's it for this video. We have now basically laid all the groundwork for our local development setup, the API. Our auth system is in place, so we are ready to continue to add features onto our API and to build out the full application here. In the next video, we will probably get started by introducing our front-end application and integrate with the couple of existing endpoints that we have, and then we can build the API and the front end in parallel as we continue to build out all the features for this application. So I will see you in the next video.